Students, welcome to the next video of integration. In today's video, we are going to see the example of the type integral linear equation upon quadratic equation, okay, or linear equation upon under root of quadratic equation. So what I mean is, as you can see here, integral of the form integral px plus q upon ax square plus bx plus c dx, or integral px plus q upon under root of ax square plus bx plus c dx. Okay, if the integral is given in this form, then how to integrate this? So example 1 is integral x upon x square plus 3x minus 4 dx. Okay, so numerator is x and denominator is a quadratic equation. Okay, numerator is a linear equation and denominator is a quadratic equation. Now denominator is a quadratic equation, but as the numerator is not a 1, if the numerator is 1, then we will apply the third term method, but here numerator is linear equation, and that's why the procedure is a totally different. Now what I have to do, I have to find the first step is find the derivative of denominator. Okay, so I'm going to find derivative of x square plus 3x minus 4. Now derivative of x square is 2x, then derivative of 3x is 3 and derivative of 4 is 0. Okay, so I will get derivative as 2x plus 3. Okay, this is the derivative. After getting the derivative, this is the first step. Okay, first step is find the derivative. Now after I got the derivative, then in second step what I will do, I will write the numerator in the form of derivative of denominator. What I mean is, see, I am writing this x, numerator is x, as a into derivative of denominator, means a into 2x plus 3 plus b. Okay, see once again, first step is I am finding the derivative of denominator. In second step, I am writing numerator in this form. Okay, a into 2x plus 3 plus b. Okay, now in third step, in next, we will solve this right hand side and then we do the comparison. So a into 2x, that will be 2ax plus 3a plus b. Okay, so x is equal to this. Now we'll do the comparison. We'll compare both the side. Now in left hand side there is a x and here in right hand side there is a 2ax. So by comparing this we get 1 is equal to 2a. Okay, and in left hand side there is a no constant term, so 0, that is equal to, here constant terms are 3a plus b. Okay, by comparing both the sides we will get the 1 is equal to 2a and 0 is equal to 3a plus b, these two equations. This is the equation 1 and this is the equation 2. Now from equation 1 I will get a is equal to 1 upon 2, a is 1 upon 2. Okay, now I am dropping this side, so it will take few seconds, so just wait. Okay, now I got the a as 1 upon 2. Now I will substitute this a in second equation, so I will get 0 is equal to 3 into 1 upon 2 plus b. Okay, so that means 0 is equal to 3 upon 2 plus b. So b is equal to minus 3 upon 2. Okay, so a is a 1 upon 2 and b is a minus 3 upon 2. after getting this a and b value, what I have to do? I have to substitute this a and b. So I will substitute this a and b in this. So I have to rub this side. So it will take few seconds. So while applying this method, you have to just focus on numerator. If numerator is other than 1, then only you can use this method. If the numerator is 1, then it is very simple. You can find the third term and then you will solve the sum. Okay. Now I got a as 1 upon 2. So 1 upon 2 into 2x plus 3. And b I got as 3 upon 2. So minus 3 upon 2. Okay. Now after getting this part, what I have to do? I have to write this I. So now my original question will be x. Numerator was x. But in place of x, I have to write this whole term. So I will write 1 upon 2 into 2x plus 3 minus 3 upon 2. Okay, upon denominator was x square plus 3x minus 4 dx. Okay, now that is equal to, now I am going to split this numerator. So I will write this as you can see here. See this step. Okay, this can be written as 1 upon 2 is a constant. So I will take this 1 upon 2 out from the integration. So 1 upon 2 integral, then here it comes 2x plus 3 upon x square plus 3x minus 4 dx. Then minus second term is 3 upon 2. So 3 upon 2 is constant, so it will come outside. So 3 upon 2 into integral 1 upon x square plus 3x minus 4 dx. Okay. Now the first side, this side is numerator is the exact derivative of denominator, right? It is in the form of integral f dash x upon f of x dx, and that is equal to log f of x plus c. Okay. Integral f dash x upon f of x dx, that is equal to log f of x plus c. Okay. Now second part is 1 upon quadratic equation. So 1 upon quadratic equation. So what we have to do? Here we have to find third term. Then we have to add and subtract the third term. Right? We have to apply the third term method. So this part will be, this will be 1 upon 2, right? Then integral of this part, numerator is a derivative of denominator, hence it will be log of x square plus 3x minus 4. Then minus 3 upon 2, right? Then here we have to use the third term method. So third term will be, third term is half into coefficient of x. Coefficient of x is 3 whole square. So that means 9 upon 4. So I am adding and subtracting 9 upon 4. Okay. So that will be integral dx upon x plus 3 upon 2 the whole square minus 5 upon 2 the whole square. Okay. And here I have to apply this formula, integral 1 upon x square minus a square dx formula. So that is equal to 1 upon 2a into log x minus a upon x plus a plus c. Okay. So by using that formula, we get 3 upon 2 into 1 upon 2 into 5 upon 2 into log x plus 3 upon 2 minus 5 upon 2 upon x plus 3 upon 2 plus 5 upon 2 plus c. Okay, so that is equal to half log x square plus 3x minus 4 minus 3 upon 10. This 2 cancel. So 3 upon 10 into log 2x minus 2 upon 2x plus 8. Okay, so that is equal to 3 upon 10 log x minus 1 upon x plus 4 plus c. Okay, so once again I am repeating this. If numerator is other than 1, okay, if in numerator we are having linear equation and in denominator we are having quadratic equation, then first step is find the derivative of denominator. Okay, then second step is write numerator in the form of derivative of denominator. Okay, then third step is find constant a and b. Okay, then fourth step write I or rewrite I in new form of numerator. New form means in form of capital A and B. Okay, and then split A and B and then integrate both the terms by using the proper integration formula. Okay, now let's see one more example. So second sum, as you can see, second sum, I guess this is the second sum. Numerator is 2x plus 1 and denominator is under root of 5 minus x square. But as you can see, when we find the derivative of denominator, okay, this 5 minus x square. So when we find the derivative of denominator, then we get derivative of 5 as 0 minus derivative of x as 1 and derivative of x square as 2x, right? So that is equal to 2x plus 1, right? Minus is common. So minus 2x plus 1. Now, as you can see here in question, numerator is 2x plus 1. Just minus sign is missing, right? So what I am going to do, I am going to multiply and divide by minus. So now I will be minus integral minus 2x plus 1 upon under root of 5 minus x square dx. Okay, now you can see the numerator is exact derivative of denominator, and we know that integral f dash x upon root f of x, that is equal to 2 into root f of x plus c. Okay, so 2 into this term as it is. So integral will be 2 into under root of 5 minus x square, and this minus sign as it is. So minus 2 under root of 5 minus x square plus c. Okay, so point is, whenever you are having numerator other than 1, then first you have to check what is the derivative of denominator. If the numerator is exact derivative of denominator, or you can make the numerator as the derivative of denominator, okay, then you will directly use the result. So with this I am concluding this type of integration. So thank you very much.